Good evening, everyone, and I hope you are well. Today we are continuing with our revision session on mathematics paper 2. We will be proving theorems, and after proving we'll be applying them, so stay tuned for all the videos that I will be posting. And if you need more clarity, you can comment in the comment section below and suggest me to do more videos. So today we are going to be proving cycle theorems. We will also prove the proportionality or the similarity theorems, and just to make these videos short, I will upload those videos one by one. I will not upload all of them at once. So let's start with this problem here. We will prove the first theorem from grade 11. If you are a grade 11, this will be very helpful for you too. So watch this video to the end so that you learn and apply what you have learned in your examination. So let's start. It says in the diagram below, O is the center of the circle. OP bisects AB at P. OB, they're talking about OP bisects AB at P. Bisects this here. Hence we have 90 degrees this side and 90 degrees this side. And with that being said, prove the theorem which states that if OP bisects AB, then AP is equals to PB. So how do we prove this theorem? And if you remember the converse of this theorem, it states that the line drawn from the center of a circle perpendicular to a chord bisects the chord. This line here, drawn from the center perpendicular to a chord, bisects the chord. And when it bisects the chord, we expect this two length here, namely AP and PB, to be the same. So how do we prove this formula? I'm gonna make few constructions. I'm gonna pause this video because I don't want to make sketches that will confuse you. So I will join AO and join OB. Like I said, I drew this line here, OA and OB, and in my construction I will state that join OA, join OA and OB with these symmetric lines here. And in our RTP, we are required to prove that AP is equals to PB. This is what we are required to prove here. And in our proof, we will say that in triangles, let me say, in triangles OPA and OPB and OPB, first of all we will say angle P is equals to 90 degrees. P is equals to 90 degrees. The reason we are given that, and then we will say, I want to check something. Here is supposed to be angle P, angle P1, P1 is equals to angle P1 is equals to angle P2 is equals to 90 degrees. Of course, we are given that, and we can say OA is equals to OB. What is the reason for that? Of course, they are the radii of this circle. If you're not familiar with the radii, I like to say radiuses because I don't want to confuse many people. So this OA and OB are the radiuses of this circle here. And one other thing we can say is that if you look here, OP and OP, it appears in both triangles. So we can say OP is equals to OP. The reason is that OP is common in both triangles, like this here. We can see that these triangles here, triangle OPA, triangle OPA, and triangle OPB, and triangle OPB, let me cancel this one. I want to say this triangle here, these triangles here are congruent. When we say triangles are congruent, it means that everything about them is the same. This length here is the same as this length here, and then this length here is the same as the length in both triangles, because we proved that OP is common in both triangles here. Therefore, these sides here also should be equal, because everything about these two triangles are the same. So the reason we are saying this these two triangles are congruent is that they both have 90 degrees, and they both have hypotenuse, and they both have the one other side that is equal. We have 90 degrees in both sides. We have hypotenuse, or hypotenuse, however you want to call it. They are equal here, and also these sides here are equal. Therefore, AP is equals to PB. We have proved that, and like I promised in the beginning, we will prove and apply what we have proved in a scenario. So I'm gonna bring another problem concerning this theorem 1 application. So I'm gonna put this aside and let's work on this one here. It says here in the diagram below, O is the center of the circle and OM is 12 centimeter. OM is 12 centimeter. They did not write that for us, so we will write it for ourselves. And it says here MN, we are talking about this here, MN is equals to 8 centimeters. We are given that this is 8 centimeters. That means the radius of this circle here is 12 plus 8, which is 20 centimeters. So it says here, determine the length of AB. We must determine the length of AB, this whole length here. If we can find the length of here, we can double it to get AB. But how are we gonna start here? I'm busy talking and I realized that this problem here is kind of like those problems, that we have to think outside the box, but not too much outside the box. But yeah, let's try to solve this problem here. I don't know if but let's try it. I'm gonna construct a line here. the line that goes from O to B, and I'm gonna show you how it looks like in a second. And this is how it looks like here. And if ON is a radius, then that means OB is also a radius and is also equals to 20 centimeters. But I know someone might say, but this does not look like 20 centimeters. And remember that this sketch here is not drawn to scale. So just for example and not for confusing anyone, we will say this is 20 centimeters. OB, ON, and OA, they are all the radiuses of this circle here. Since we have 20, we have 12 here, we can find MB. So we are gonna say MB squared is equals to OB squared, OB squared minus OM squared, OM squared. We're gonna say it's Mr. Pythagoras here. Pythagoras theorem, or can say PT, does not matter. MB squared is equals to MB squared is equals to, what is OB? OB is 20. We're gonna say 20 squared minus OM. What is OM? OM is 12 minus 12 squared. MB squared is equals to, so the calculator, 20 squared minus 12 squared, it gives us 256. Remember that this is MB squared. We want MB, so we can take the square root of both sides. Since we do not want a negative length, we will ignore the plus or minus sign and only take the plus sign here. So square root of 256, let me check. 256 is 16. Yeah, it's 16. MB is 16 units. If MB is 16 units, then if MB is 16 units here, that means AM is also 16 units. So we can say 16 units. We can say 16 units or 16 centimeters, since they give us therefore we can say AM plus MB is equals to AB. We said AM is 16 and we said MB is 16. We proved it in the previous theorem. Is equals to AB. You can put it well by saying 16 plus 16, I believe that's 32. You can confirm it in your calculator, and this is how we answer this question. I will see you in the next theorem, and if you want more clarity, you can comment down below and I'll try to explain as fair, or I'll try to explain as further as I can.